Okay, so today we start chapter 5 of the Transmath Catrium book. This is the book that you were supposed to have done last year. So, in this chapter, it's on multiplier, diviser des quotients, which means multiplication and division of quotient. Quotient is the same as fractions. So, in the previous chapter, we saw how to add and subtract fractions. In this chapter, we will see how to multiply and divide fractions. You probably already know how to do this, but still I will go a little bit into detail, and this because it's interesting to see the concepts of multiplication and division as applied to fractions. You can be given rules, and I will of course give them to you, and so you can just blindly follow them, but you should also understand what's behind these rules, what is actually meant by multiplication of fractions, what is actually meant by division of fractions or division by fractions. So this is what we will do. Now these are the two main topics of this chapter, but this first video I will only take the multiplier, the multiplication. The division I'll put a second video for that, because that is a concept is a little difficult to understand as applied to fractions. Only a little difficult, but I'll devote a separate video to it. So here we will start with, let me get this paper, and so chapitre 5, multiplication et division de quotient. Quotient is the same as fraction. Okay, so multiplication, what does it mean? What do we mean by multiplication? What do we say 2 times 3 or 3 times 2? What does it mean? So basically it means we take that many times of something else. We take that many times of something else. So the first number and the second number. So let's say if I say 2 into 3, that means I'm taking 2 3 times. Take 2 3 times. So it means 2 plus 2 plus 2, which we see is 6. If we take 2 into 3.5, we get 2 plus 2 plus 2. This is for the 3 here, and for the 0.5 we can add another 2 into 0.5. So we get 2 plus 2 plus 2 plus 1, which is equal to 7. This is simple. This you've learned many years ago, and but this is what it means. You're taking 2 3 times. Now interestingly, multiplication is a commutative operation, which is just a fancy way of saying that if you take 2 into 3, it is same as 3 into 2. Not all mathematical operations are commutative. The simplest example is division. 2 divided by 3 is not the same as 3 divided by 2, but multiplication is commutative. Just like addition is commutative, you can say 2 plus 3 is equal to 3 plus 2. But anyway, because here if you take 2 into 3, it is 2 plus 2 plus 2. You are taking 2 3 times, and if I do 3 into 2, I am taking 3 2 times, and both of these are equal. 6 is equal to 6. Okay, so now let's come to the fractions. What do you mean by multiplying a fraction by an integer? Let's start simply. First we'll multiply a fraction by an integer, then we'll multiply an integer by a fraction, and finally we'll come to multiplying a fraction by a fraction. So that's why this video is going to be a little longer, and that is why I'm making a separate video, or I will make a separate video for the division. Okay, so let's take a fraction, 7 divided by 8. This is a fraction. We multiply it into 2. That means I take 7 divided by 8 twice. 7 divided by 8 plus 7 divided by 8 gives me, we know this, how to add these fractions. The denominators are already common. It's 8. So you put 7 plus 7 there over 8. You get 14 over 8, which if you simplify, you'll get 7 over 4. Okay, very simple. So what do you see here? If I redo this, if I just copy it here, I copy this here, but here 14 is actually 7 plus 7, which can also be written 7 into 2. So just remember that instead of adding here, we could just be multiplying 7 into 2. 7 into 2, that's the definition of multiplication, taking that many times, take times of something else. So here we get 14 over 8. Okay. So this is simple. Now let's try to do this in a graphical way. How do we do this? I mean, we take a fraction 7 to 8 into 2, but let's take another example. We'll take quarter into 3. Okay. So I draw a box. To retain your interest, we'll call it a pizza. So I have a square pizza. Have you ever seen square pizzas? Yeah, a lot of places they actually, in many countries, they make pizzas in huge areas, not the round pizzas that we are used to, but they make pizzas in a tray which can be very, very big, and they cut them into rectangles or squares. So, okay, suppose I have a square pizza and I take 1/4 of the pizza. So I divide it into 4 and I mark out 1/4. Now if I have to multiply this into 3, that means I take 3 of these sizes, 3 of these quarter pizzas, and what do I get? I get 3 over 4. So basically this is what I have said there. If you take 1 over 4 into 3, you get 3 over 4. If you do it the normal way, or the way, not the normal way, but the way we decided earlier, 1 over 4 into 3, 1 over 4 plus 1 over 4 plus 1 over 4, this gives us this gives us 3 over 4. So basically this I have just showed here in a slightly graphical form, so that we have a pizza, we take a quarter of that pizza, but if we took 3/4 of the pizza, 3 times of that, then we will get these many pieces, and this is 3/4 of the whole pizza. Okay, so I turn the page and we come to the opposite thing. If we multiply an integer by a fraction, so there I have taken 1/4 into 3, here I am going to take 3 into 1/4, so that I am multiplying an integer by a fraction, 3 into 1/4. So what do I get here? So then basically I have 3 pizzas, because that's the 3 pizzas, and I have taken quarter of them. So that is, I take a quarter of each. So again I see, if I add this plus this plus this, the hatched portions, then I'll get 3 over 4. So whether I multiply an integer by a fraction, or as on the previous page, a fraction by an integer, I get the same answer. And of course this is the rule of commutativity is verified. 3 into 1 over 4 is equal to 1 over 4 into 3. And now we come to the big one, or the general case. Let's not call it the big one, let's call it the general case. Multiplying a fraction by a fraction. So let's say I have 3 over 4 into 1 over 2. So basically, again, in our English terms, in language, I want to take half times 3 over 4. So let's take, first we'll mark out 3 over 4. So this is 3 over 4 of a pizza, 3 parts out of 4 parts, 3/4 of a pizza, and then I take half. So just like I took 1/4 of 3 there, here I want to take half of this area, or these 3 slices of pizza. What I do is I cut them into half, and I take half of each. So I take half of there, I take half there, and I take half there. I don't take half from there because we are not taking half of that anyway, we are only taking half of this shape. So I've taken half, and to take half I have to divide each one of these into 2 pieces. So essentially, instead of having a pizza that was divided into 4, now I have a pizza that is divided into 8 pieces, and now I'm taking 3 pieces out of the 8. So the answer is 3 over 8. So we get 3 divided by 4 into 1 over 2 is equal to 3 over 8. What if we turned it around? What if we said we'll take 3/4 of half a pizza. That means not half of 3/4 of a pizza, but 3/4 of half of a pizza. That is, here I have half a pizza, I take 3/4 of that. So again I take the pizza, I mark out half, this is my half of a pizza, and then I take 3 out of 4 of those. So that part I have to divide it into 4. So I've divided that into 4 and I take 3 of those. So basically if I divide the whole thing into each one of these, both these halves into 4 pieces each, so I'll get this. So here also I get 3 out of 8, because now the pizza is divided into 8 pieces and I'm taking 3 pieces out of those 8 pieces. So here also I get 3 over 8, there also I got 3 over 8. So basically 3 over 4 into 1 over 2 is equal to 3 over 8. Now what pattern do you see here? You see that 3 is equal to 3 into 1, 8 is equal to 4 into 2. So multiplication is the easiest of all the operations of the 4 operations with fractions. Addition, you saw you had to do a PPSAM, or not even a PPSAM, any SAM, that is any common multiple you had to do if you wanted to add 2 fractions or more than 2 fractions. Here you have to do nothing like that. The rule is very simple. Multiplying fractions, multiply the numerators, multiply the denominators, and simplify if possible. I didn't have space here, so I'll have to turn over the page, but this is it. This is the rule of multiplying fractions. A over B into C over D is equal to A into C over B into D, where B and D both have got to be not 0, because if either one of these is 0, you'll have division by 0, which is not an operation that is defined in mathematics. So this is the general case. It is true always, always, always. And all the cases we took here of multiplying an integer by a fraction, or multiplying a fraction by an integer, or multiplying 2 integers, everything applies to this. This rule applies to everything. So we'll take examples. 2 over 3 into 15 over 8, you get 2 into 15, divided by 3 into 8, you get 30 over 24. 2 into 15, 3 into 8, 30 over 24, which if you simplify, you divide both numerator and denominator by 6, you get 5 over 4. So 2/3 of 15 over 8 is 5/4, or 15/8 of 2/3 is 5 over 4. Let's take another example. 6 into 12 over 5. So here we don't have a fraction, but what is 6 equal to? 6 is equal to 6 over 1. So you can write 6 over 1. So you can write it as 6 into 12 divided by 1 into 5, which is 5. So you'll get 72 over 5. So this applies for integers also. If you're multiplying an integer with a multiplying an integer into a fraction. Okay, what if you have negative numbers? So here I've taken a longer thing. So it doesn't only apply to 2 fractions, it applies to as many fractions as you are multiplying. So I got minus 23 over 79 into 63 over 28 into 18 divided by minus 4. So yeah, I have 2 negative numbers, one there, one there. So I can write minus 23 into 63 into 18 divided by 79 into 28 into minus 4. Don't forget the brackets. So if I multiply that out, I've done it on my calculator, I get minus 26,082 divided by minus 88,048. Dividing a negative number by a negative number, you get a positive number. In common terms, we can say the minus cancels out. I don't really like that term cancels, but it's so handy because it is not really a mathematical operator, but you have minus and minus, so that becomes plus. I saw that both of these numbers were pairs, so I divided them by 2 and I simplified it to. Okay. So what if I was multiplying, say, 0 over 12 into 2 into 3? So even that I could do. It'll be 0 into 2 over 12 into 3. I'll get 0 over 36, which is equal to 0. So this rule even applies if A or C are 0, not B and D, because division by 0 is not defined. Okay, so that is all for multiplication. But there is one aspect, one other definition we have to learn, and that is inverse of a fraction, in French, inverse. Inverse d'une fraction, définition. Si on a une fraction A sur B, son inverse est B sur A, où A n'est pas égal à 0 et B n'est pas égal à 0. So what you do, this is just a definition, it's not an operation, no? It's just a definition. If you have a fraction A over B, its inverse is B over A. Why is this so? Why I'm telling you? Because this will be useful in division of fractions, and you probably already know this, but we will come to that in the next video. So, and always A over B multiplied by its inverse will always give 1. Always, whatever be the value of A over B, because A over B multiplied by B over A gives us AB into BA, divided by BA, it is AB over AB is equal to 1. What is that funny mark there? That shouldn't be there. There. Oh, now the equal sign is covered up. So, there. Right. So, for example, if the fraction is 7 over 8, its inverse is 8 over 7. In English, it's known as, I've written it somewhere, we'll come to it. If my fraction is equal to 2, what do you mean fraction is equal to 2? Okay, if I have 2, what is its inverse? Its inverse is 1 over 2, because 2 is actually equal to 2 over 1. So inverse of 2 is 1 over 2, and similarly inverse of 1 over 3, the inverse is 3 over 1 is equal to 3. Please don't write any answer like this. I've seen some of you write an answer 3 over 1 or 16 over 1. Please, no. That is always, you can eliminate the 1, because anything divided by 1 is the same thing. In English, it's called inverse, and I forgot why I didn't write that, and it is also known as the reciprocal. So, I should have written here also. So, say if a number is 2.45, then its reciprocal will be 1 over 2.45. This applies to all these terms, inverse and reciprocal, apply to all numbers, not necessarily fractions. Okay, so this is enough for today. But I'll give you, as always, 3 video problems, in-video problems, so that I can see whether you watched the video and understood. And these are these 4 simple problems. Here, I'm asking you to multiply 3 fractions, minus 12 over 7 into minus 16 over 9 into 35 into 5 over 12. In B, I'm asking you to do this calculation. There's addition within this bracket, there's a subtraction within this bracket, so you have to do this. Here C, you have to just write the inverse of 8 over 16. And D, you have to write the inverse of 0 over 12. Now in any one of these, whenever you come to an answer, try to see whether you can simplify. If your answer is a fraction, try to see whether you can simplify it. So I will stop here, and tomorrow I will upload a video on division by fractions and division of fractions by other fractions. So that is going to be a little bit more complicated, and once we do that, then we'll jump into the problems in this chapter. We'll try to finish it quickly. Okay, I stop here.